Hello, thank you for joining us. In this video, we'll look at some examples of finding partial fraction decompositions, which can be very useful within some advanced areas of mathematics, in particular with calculus and being able to work with some integration techniques. Right, but this is a concept from algebra that we want to make sure we understand. So if you're ever asked to find a partial fraction decomposition, so let's say we have this expression, right? Then really what we're trying to do is reverse the process used to combine multiple fractions into a single fraction, right? So if we have 1 over x squared minus 3x plus 2, we could think about, well, what are the factors of the denominator, right? And the factors of the denominator are x minus 2 and x minus 1. So really we can say, hey, what were the two expressions, what were the two fractions that we combined to a single fraction to get 1 over x squared minus 3x plus 2? Okay, so what we can do with this work is be able to say, hey, if I think about how I combine, right, if I think about how I combine two fractions to get a single fraction, we'd say, well, first I need to get a common denominator, right? And that common denominator would be this x minus 2 times that x minus 1, right? So the a term in the numerator needs to be multiplied by an x minus 1, and the b term in the numerator needs to be multiplied by an x minus 2, right? Because really we're saying, hey, this term over here needs to be multiplied by x minus 1 over x minus 1, and this term over here needs to be multiplied by x minus 2 over x minus 2, right? So then we have a common denominator, and we're saying, hey, that this numerator needs to end up being 1. Well, if I have the denominators the same, I can set the numerators equal to each other, right? And one of the approaches for solving this would be to select values of x to allow solving for the unknowns, right? So if I solve where x is 1, then x minus 1 is going to be 0, and we're going to have that b times 1 minus 2 will be equal to 1, or in other words, negative b is 1, so that would mean that b is negative 1, right? And then similarly, we could select x to be equal to 2, and this term would go to 0. And if x was equal to 2, then it would imply that a is equal to positive 1, which then with a being positive 1 and b being negative 1, and us saying that we could decompose our fraction into these two um, separate fractions, then I have this decomposition that 1 over x squared minus 3x plus 2 can be written as 1 over x minus 2 minus 1 over x minus 1. So let's try a few. Let's say we have this first one over here, 2x minus 5 over x squared plus x minus 2. So how could we find this in partial fractions? Well, we could say a over something plus b over something else needs to be equal to 2x minus 5 all over. Well, let's go ahead and factor that denominator. And that would be x plus 2 times x minus 1. So I can say a over x plus 2 plus b over x minus 1 needs to be equal to this fraction. How am I going to work through there? Well, this term on the left needs to have the numerator and the denominator multiplied by x minus 1. And this term with b has to have numerator and denominator multiplied by x plus 2 over x plus 2. Right, which then leads me to a times x minus 1 plus b times x plus 2 all over x plus 2 times x minus 1 must be equal to 2x minus 5 all over x plus 2 times x minus 1. Now, because this process will be the same every single time based on the algebra of combining fractions from these rational expressions, we can really then just focus on those numerators, right? We can focus on the numerators and say that, hey, a times x minus 1 plus b times x plus 2 needs to be equal to 2x minus 5. Then if we select x to be 1, then that would mean that b times 1 plus 2 is going to be equal to 2 times 1 minus 5. So in other words, 3b is going to be equal to negative 3, which would mean that b is negative 1. Right? Because of course if x is equal to 1, then 1 minus 1, that term goes to 0. Okay? If we let x be equal to negative 2, then I have a times negative 2 minus 1 plus b times 0 is going to be equal to 2 times negative 2 minus 5. So in other words, what we would have there is that negative 3a would be equal to negative 9, which would imply that a is going to be equal to 3. So then that tells me that the partial fraction decomposition is going to be 2x minus 5 all over x squared plus x minus 2, that will be able to be decomposed as 3 over x plus 2, right? And then minus 1 over x minus 1. And once again, where did I get that x plus 2 and that x minus 1? From the original setup that I had for the equation. So the partial fraction decomposition, or expressing this in partial fractions, would be given by that expression. Okay. If we look at another example, we say, hey, find the partial fraction decomposition of what we have here, right? Well, if we factor the denominator, right, we have x minus 1 and x plus 1. So that means that we can think of this as something over x minus 1 plus something else over x plus 1, and that needs to be the same as x over x squared minus 1. Right? If we multiply both sides of the equation by a common denominator, that would tell me that a times x plus 1 plus b times x minus 1 must be equal to x. Right? And if x is equal to 1, then 2a is equal to 1, which would mean a is 1/2. And if x is equal to negative 1, then negative 2b is equal to negative 1, which would indicate that b also happens to be 1/2. And so therefore our partial fraction decomposition is given by 1/2 all over x minus 1 plus 1/2 all over x plus 1. That's our decomposition. We could always check to see if we've done our work correctly and say, hey, what if I wanted to write these as a single fraction? Well, I'd have 1/2 times x plus 1 plus 1/2 times x minus 1 all over x squared minus 1, because the product of those denominators, which would just be 1/2 x plus 1/2 plus 1/2 x minus 1/2 all over x squared minus 1, which gets us our original expression, x over x squared minus 1. So you can always check your work. Okay. Notice some people might write this instead as 1 over 2 times x minus 1 plus 1 over 2 times x plus 1. Doesn't matter your approach, but we need to be consistent and make sure that we are able to work through these partial fractions. Thank you for your time.